Hello again, thank you for watching my videos and welcome to this chapter on the steps of machine learning process. We have identified 7 case steps in this process and I will guide you through each one of them to prepare you for what's upcoming, which is coding. The first step is problem definition. Problem definition is the initial and one of the most crucial steps in the machine learning process. It involves clearly identifying the specific problem you want to solve and understanding the object and the goal. This step sets the direction for the entire project and helps determine the scope, data requirement, type of machine learning you can use, and success criteria. During the problem definition phase, you should first understand the problem, clearly articulate what the problem is and why it needs to be solved. Understand the context and the background. Second, define objectives. Establish what you want to achieve. This could be improving accuracy, reducing costs, increasing efficiency, etc. Third, determine success metrics. Decide how you will measure success. This would be metrics like accuracy, precision, recall, F1 score, and other relevant metrics. Fourth, identify constraints and assumptions. Recognize any limitation or assumptions that could affect the solution. Imagine you and your friends are on a mission to find the best cookie shop in town. You're part of the Cookie Connoisseur Club and you want to build a machine learning model to help you out. The first thing you need to do is define your problem clearly. What's your objective? You want to find and recommend the best cookie shop in town. What type of output do you need? A list of top 5 cookie shops with ranking and reviews. How will you measure success? By comparing your model's recommendation to expert review and user satisfaction scores. And what constraints do you have? Limited data, quick recommendations, and budget constraints on computational power. The second step is data collection. This step involves gathering the necessary data that will be used to train and evaluate the machine learning model. The quality and quantity of the data collected directly impact the performance of the model, making this a crucial step. For unsupervised learning, this is unlabeled data with unknown patterns that we intend to discover. For supervised learning, this is the labeled historical data that we intend to use to train and evaluate our model. For reinforcement learning, this is the data that helps our agent learn which actions yield the most reward. Continuing with our Cookie Connoisseur Club example, let's move on the data collection step. Your mission is to gather all the necessary information to find the best cookie shop in this city. So, you need to collect data on cookie shops, including reviews, rating, locations, and menu items. For example, we might scrap reviews and rating from Yelp using their API. We collect details like shop name, for example, some shop called Cookie Heaven. The rating will be 4.8. A review can be the best chocolate chip cookies I ever had. And the location, let's say 123 Cookie Lane. The third step is data exploration. This step involves examining the data you have collected to understand its structure, patterns, and key characteristics. By exploring the data, you can identify any issues or insights that need to be addressed before moving on to the modeling stage. The key elements of data exploration are summary statistics. We can calculate basic statistics like mean, median, mode, standard deviation, and range for numerical data. Visualization. Charts and graphs like histograms, scatter plots, box plots, and bar charts can help a lot in visualizing data distribution and relationship. Data distribution, we examine the distribution of different features to understand their spread and central tendency. Missing values, identifying any missing or null values in the dataset and decide how to handle them. Outliers, detect and investigate any outliers that could affect the model performance. And finally, correlation. Analyze the correlation between different features to understand their relationship. Continuing with our Cookie Connoisseur Club example, let's move in on data exploration step. Your mission is to explore the data you've collected to find the best cookie shop in the city. So, in this step, you will be analyzing and visualizing the collected data to uncover any patterns or insights that the data might have. For example, we might use a bar chart to visualize the average rating of different cookie types. Here we have two different bar charts, one run with R and the other one with Python. By exploring our data, we gain valuable insights that helps us understand the landscape. This exploration sets the stage for building a powerful machine learning model. The fourth step in machine learning process is data preparation. It's the process of transforming raw data into a clean and structured format that can be used for modeling. Proper data preparation is crucial as it directly affects the performance of the machine learning model. The key elements to data preparation involves data cleaning, which means handling any missing values, removing duplicate, and correct error. Data transformation, normalize and standardize numerical data, encode categorical data, and create new features if necessary. Data splitting, dividing the data into training, validation, and test set. Feature selection, selects the most relevant features for the model to improve efficiency and performance. Data augmentation, create additional data samples if needed, especially in the case of image or text data. Continuing on our cookie connoisseur club example, let's move in to the data preparation step. Your mission is to prepare the data you've collected on cookie shops to ensure it's ready for modeling. For example, our cleaned and prepared data might look like this. The shop name Cookie Heaven rating will be normalized to 0.9. From 4.8 it will become 0.9. The reviews will be processed so it becomes best chocolate cookie chip. So we remove it stop words and we use stemming, and the cookie type will be encoded from chocolate chip to 1. Successful data science hinges on having good idea. It doesn't need to be flawless, but it should be reliable and relevant. You probably have heard of the saying, garbage in, garbage out. This couldn't be more true for machine learning. The importance of a good data cannot be overstated. In fact, it's common for data scientists to spend up to 80% of their time on data collection, exploration, and preparation. This meticulous process ensures that the data we use is clean, accurate, and ready for analysis. The fifth step is model selection and training. This step involves choosing the appropriate machine learning algorithms that will best solve the defined problem. The choice of model can significantly impact the performance and accuracy of our prediction. The elements for model selection steps are problem type. So you identify whether the problem is a classification, regression, clustering, or other type of tasks. The algorithm choice. We need to select algorithms that are well suited for the problem type and data characteristics. Cross-validation. You need to use a technique like key-fold cross-validation to assess the model performance and ensure it generalizes well to new data. Don't worry if you don't understand what cross-validation technique is. It's a simple validation technique that we will try to cover on the coding section. Continuing on our cookie connoisseur club example, your mission is to try out machine learning models to recommend the top cookie shop in our city. So our problem is a classification task. We need to classify cookie shops into categories like top rated, average, and needs improvement based on their rating and reviews. There are multiple classification algorithms that we can choose from. But how can we choose from all these algorithms? Well, the next step is the answer. So, the final step of the machine learning process is called model evaluation. This step involves assessing the performance of the trained model to ensure it meets the required standards and perform well on unseen data. Evaluating the model helps in understanding its accuracy, precision, recall, and other metrics, which indicate how well the model will perform in real-world scenarios. The key elements to model evaluation are evaluation metrics, like using appropriate metrics such as accuracy, precision, recall, F1 score, mean squared error, depending on the type of problem you are solving. A classification problem, a regression problem, a clustering problem, and so on. Confusion matrix. For classification problems, use a confusion matrix to visualize true positive, false positives, true negatives, and false negatives. Cross-validation. Perform a cross-validation to ensure the model generalizes well to different subsets of data. ROC curve. For binary classification problems, use the ROC, which is receiver operating characteristic curve, and ARC, which means area under curve, to evaluate the model's performance. Bias versus variance trade-off. Assess the bias-variance trade-off to understand if the model is overfitted or underfitted. Don't worry again if you don't understand some of these terms. We will cover them all in the coding section. So, in supervised learning, our goal is to predict a label or a value. We evaluate a model by measuring its accuracy in predicting labels for previously unseen data. In contrast, unsupervised learning often requires a more subjective evaluation. A good unsupervised learning model is one that produces results that are meaningful and intuitive to us. So depending on a model's performance, we might need to rebuild it using slightly different data or the goal is to make changes that significantly improve the model's accuracy and effectiveness. This process is typically iterative, involving repeated adjustments and evaluations to achieve the best possible result. Now, the final step of the machine learning process is called model deployment. This step involves deploying the trained model into a production environment where it can make real-time prediction on new data. It also includes ongoing maintenance to ensure the model continues to perform well over time. The key elements to this step are deployment. Move the model from a development environment to a production environment. Integration. Integrate the model with existing systems and workflows. Monitoring. Continuously monitor the model's performance to detect any issues or drift. Updating. Regularly update the model with new data to keep it accurate and relevant. Scalability. Ensure the model can handle increasing amounts of data and requests. And there you have the essential steps of the machine learning process, from data collection and processing to model training and evaluation. Each step is important for developing accurate and reliable machine learning models. Remember, the key to successful machine learning lies in understanding your data, choosing the right algorithms, and continuously refining your model. Thank you for watching and happy learning.